So my name is Marian Varga, and if you want to know more about me, the best way is to go to this site lovetointegrate.com, and if you go there you'll see that I recently published a book titled Mastering RESTful Web Services with Java, and that basically says it. I've worked with Java for my whole professional career, which is over 20 years, and also even longer. I've always been interested in connecting software systems, so that's why I love to integrate, and that's why I wrote a book about APIs. If you register on that page, you will get a free chapter from the book as a gift from me. The chapter is about performance and scalability, and that's very relevant because on today's talk we will also mention these topics. Now let's move to you maybe. So let's test the chat again and just tell me the newest version of Java that you're using in production on your project. Yeah, we can see 21, nice, 17, okay, 21 is it's the same for me actually. And now maybe to make it more interesting, are there any older versions of Java that you're still using? No? 8. Oh, I was expecting this. 11. 11 is not very popular, but still it is used. I can see. Okay. 8 is very popular still. Okay. Nice. Okay, let's move on. So basically, what I want to maybe help you with is upgrading to newer version of Java, and that's the why from the title of my presentation. Of course, there are with every Java version we get new features, small and bigger ones, and the bigger ones they have a separate documentation, and they are called Java Enhancement Proposals, JEPs. We will talk about them later in a few minutes. Then, but of course, if you want to be allowed to upgrade your Java, you need to have a really strong reasons for that, and the strong reasons are usually either security or performance. And performance I mean, it doesn't mean that your application has to be slow, but with performance you can save resources, you can make your application consume less memory, you can shorten the startup time of your application, that improves scalability, and this way you can save money because a lot of software nowadays is deployed to the cloud, and of course if you can save resources then you save money. And what's also important, Java 25 is a Java version with LTS, with long-term support. Basically, we get a new major version of Java every 6 months since Java 8, but some versions, on some versions, there's an alignment of the different vendors that you can get Java from, that basically all the vendors provide long-term support for those versions. So they are versions like 11, 17, 21, and now the latest version with long-term support is 25. of course, it's important because most developers using Java somehow gravitate to these versions with long-term support, and also developers of libraries and frameworks usually target these versions. So it is kind of an alignment in that. Uh, and it's also important because usually when upgrading your Java, the biggest problem is not Java itself, but the problem is with the dependencies that you have in your project. You usually work with some framework or use some libraries, and my experience is that before Java 17, these upgrades were sometimes a little bit painful. That's why I feel for you if you're still on Java 8, because this is still ahead of you. I think that the ecosystem and the vendors of libraries weren't they needed some time to adjust to this situation that there's a new Java version every 6 months, and that's why it wasn't so easy to get from older version up to Java 17. I think now after Java 17 it got much easier. So last year I managed to upgrade our backends on our project from 17 to 21, and it was really easy and smooth. So once you're there, at least at Java 17, I think the upgrade should be much better. Another thing, if you are still under Java 21, 2 years ago I had a talk about Java 21. So if you're interested in that, you can look it up or just register on that page that I mentioned, and I can send you a link. Now we will concentrate on what's new since then, so from version 22 through to Java 25. So the Java enhancement proposals are of different types. Some of them are like preview or incubator features that you can try in different versions of Java, but it's not guaranteed that they will be backwards compatible in the coming versions. I want to focus on those that are final already, but I will also mention some others. Now, first type of JEPs are those that concern the Java language, and there's a group of JEPs that help beginners start with Java. Do we have any Java beginners here? Type beginner in the chat. Seems no, but maybe you have some junior friends, and we definitely need new blood in the Java community. And yeah, we have one beginner. Great, welcome. So although Java is a great language and platform that can help you do a lot of different things, it may be a little bit overwhelming for people who start, or for people who start a new project, something small, and they don't want to invest a lot of time in some boilerplate and things that are not really interested in that early stage. That's why we have these compact source files, which means you can write the main method without it doesn't have to be static, and you don't have to explicitly mention the class belongs to. And we also have this IO class that can be used to print something to the console. So the hello world is now much shorter and much simpler. Another such nice feature is the imports. There's a little bit of a dispute or different opinions on if we should use what the so-called wildcard imports, those that contain asterisk and import everything from a package. In mature projects, it's usually preferred to explicitly mention the classes instead of using the wildcard imports. But of course, in a starting project, this can be inconvenient because you would have to list a lot of classes for a short piece of code. On the other hand, using the wildcard imports is a little bit too coarse-grained and too ambiguous. Now we have a new way that's based on Java modules that were introduced in Java 9. Basically, you can import all the public classes from a module using this import module. And of course, there are cases when this can lead to ambiguity. Then, of course, the ambiguity has to be resolved by also importing that class explicitly. Another related feature is something that started in Java 11, and that's that you can start a Java program that is not compiled. You just have a file with the Java source code, and it is automatically compiled and started. There are cases when you don't really care if Java is a compiled or interpreted language, you just need something done. The disadvantage was that you had to write all the classes, the whole program in one file. Now you can separate it in multiple files, and they will be found. If you refer to some other class, it will be found by its name. So that's also nice for some cases. And there's one syntax change that goes to the very roots of Java language, and that concerns the constructor. Everybody knows constructors from object-oriented programming. In Java, we've had this restriction that when you extend the class, the first thing you need to do in your constructor is call the superclasses constructor using this super keyword. This restriction made the constructors not flexible enough. For example, if we can see that there might be some validation, and if the validation fails, we just want to throw an exception, and of course in that case invoking the superclass constructor is just useless work. And it can also make the code actually safer, because if we extend the class, we usually add some fields, and unfortunately this superclass constructor, if it's not written nicely, it could happen that it invokes methods that are overridden, and in that way it could unintentionally access your extended fields that are not initialized yet. So actually, by having the possibility to initialize your extended fields before invoking the superclass constructor, you're making your constructor more safe. So effectively, now the constructor consists of two parts. The first part is a prologue, and then from invoking the superclass constructor, it's the epilogue. And in effect, the prologue is executed from bottom up, so from the leaf child class to the root of the hierarchy, and then the epilogues are executed as before from top to bottom. And we have more nice features. For example, for Javadoc, you can now use the Markdown syntax. Many people like Markdown because it's concise, it's easy to write, and it's also relatively easy to read without having to render it, comparing to HTML. So that's definitely useful. And another nice small thing is the unnamed identifiers. So there are cases when the syntax requires an identifier, but you don't really want to refer to the identifier, you don't need it. In that case, you can just put the underscore there, and you won't have something that's not unused, and it will simplify your program. And also for lambda expressions, that's quite typical that you have some arguments, but you don't want to need it because you don't need them because you want to return some constant. So that's another useful case. We have now pattern matching in Java, so we can do these smart casts in switch. We can also deconstruct some records. There as well, it's quite typical that there are some components in your structures that you don't need. Then of course it's nice to explicitly say that you don't care, you just put the underscore. You can have even multiple such underscores there, but of course you can't refer to them. Now we move to the API. String gatherers is a little bit more advanced feature, but it can save you or help you in some cases. Basically, all of us, even those who use Java 8, know Java streams. And the typical Java stream pipeline starts with creating a stream. Then we have some intermediate operations, and then we have some collector operation. What's limiting a little bit is there are cases when you want to have non-standard intermediate operation. Like in this example, we want to have windows or sub lists of a certain length. Like we want to group these elements by 3, and for that we can define a gatherer, so-called gatherer, and there are even some predefined ones. So for such cases, now we have a place where we can extend our pipelines. Class file API is something for manipulating Java class files. There are libraries that can do it. ASM is a very commonly used one. Unfortunately, it is already a little bit legacy, its API, and so that's why when Java developers wanted to include something, they wanted to start with something fresh and new. And basically the main goal of this class file API is to have something official that will be always in sync with the class file version in Java, because now we have a new new Java version every 6 months, so it's important. Now we get to some security related features. Of course, soon maybe we will have quantum computers. Nobody knows when they will be used in real world situations, but we need to prepare. That's why we have new algorithms that should be resistant to quantum computing. And we have also a new API for the so-called key derivation functions. You probably have an idea what it is about. And also security related is that we are permanently disabling the security manager, which sounds strange. Why are we disabling something? The reason is that in reality, security manager wasn't used a lot on the back end. If it was used, it was basically misused many times for some special purposes that it wasn't intended for. So it was decided to in order to simplify Java's code and to make the maintenance easier, to just drop the support for security manager, and instead the efforts in the Java team will be focused on something more practical, like things that face internet and things like serialization that are more relevant for making your application really secure. Concurrency is my favorite topic because, as I said, I like to integrate, and in distributed systems you can't avoid concurrency because there are many things flowing around in unpredictable times in parallel. One feature that is very useful is scoped values. Basically, you can imagine it like if you have a multiple layers of your application. Some of them maybe belong to some framework, then you have some application code, and from that you again call back to some framework. This sandwich of layers has this part where you need to, and of course you want to pass some context between those parts that belong to the framework, and the primitive or naive way to do it would be to pass it as parameters, but that's not nice because the application code doesn't really care, and we don't want it to tamper with the context that it doesn't understand. So we want to hide basically some parameters and only access them where they are relevant. Traditionally this was done using thread local. Unfortunately, thread local has some disadvantages, and these disadvantages got augmented with the introduction of virtual threads, because with virtual threads we can have a really large number of threads in our application. And those disadvantages are, for example, that the thread local variables can be mutated anytime, anywhere. So it makes reasoning about them much more difficult, and nowadays we prefer to use immutable structures where possible. Another thing is there's no clear scope. It's easy to forget that you have some thread local variable set somewhere, and then it's leaked into some thread that doesn't want to have it or shouldn't have it. And if we want to have some hierarchical structure, like some thread spawns multiple subthreads. The problem is there is a mechanism for inheriting thread locals, but it's inflexible and inefficient. So now we have scoped values. You can see that the declaration is somewhat similar to thread local in that we are defining it static, but then in order to set the value, we use this where method where we it's called we bind the scoped value to some value, and then we call some typically we use a lambda expression here, and within that lambda we can access the value, but we cannot modify it. What we can do is we can start another scope, a nested scope, where we can rebind the value, but we still have a clear scope where the value starts to have where the value starts and when it ends, where the binding starts and ends. So it's much easier to reason about and therefore more secure. Now we move to the runtime, to the JVM, and maybe also some tools around it. Do we have any people who like to use Kotlin? Because I also like Kotlin. If we have such people here, I recommend also for Kotliners to upgrade to new versions. Now the latest version of Kotlin is 2.3 because this supports Java 25 bytecode as output, and this means you can combine your Kotlin code with the latest Java libraries and other code, and of course get all the great features of Java 25, which one of them is an improvement to the implementation of virtual threads, or actually not really virtual threads, but the synchronization of objects. That's a early way to handle concurrency from the start of Java, but it's still used in some libraries. The disadvantage of it was that with the introduction of virtual threads, this led to so-called thread pinning, which means the virtual thread that executes some synchronized block couldn't be reused by some other, when it's blocked, it couldn't be reused. Now it's fixed, and the only situation when virtual thread is pinned is when it's executing a native code. And of course, if it's a native code, then JVM cannot do much about it because it doesn't have control over it. Yes, native. There are definitely cases when you can't avoid it, but yes, it comes with some risks and some complications. The traditional way to invoke native code from Java was JNI. Now we have a much nicer way to access native stuff from Java. It's called foreign function and memory API. So it's recommended now. And regarding JNI, basically we are aware that native code has some risks. So now we have some ways that in the future we could use to basically forbid the use of native code via JNI, so that we can be more sure that our application is really secure, because it can't go outside of the Java world. Garbage collectors are being improved in almost every Java version. we have multiple implementations of garbage collector. It's a rather advanced topic as well, but one trend that we can see is that all the implementations are moving to the generational type, which means they distinguish between old and a young generation of objects to make the garbage collection more efficient. And in general, I would say, of course, it's an advanced and detailed topic to choose a garbage collector, but in general, I can say it's a kind of an optimization. So now I'm getting back to the topic that I'm of the free chapter of my book that's about performance optimization. Sometimes you need to really go to the top level basics. First, you need to know your load, what your application is really doing. You need to understand it, and what your input data is, and so on. You need to know your expectations well, because sometimes the same latency in some application can be acceptable. In some other application, it can be like game over, and you need to be able to measure those things so that you know if, for example, switching to a different garbage collector improves the situation or not. And you should only fix the bottlenecks and not try to fix everything, because it's impossible. There can be some edge cases that are not really important for your expectations, and then those are not important. You need to concentrate on what really brings benefit. And to measure things, a great way is to use a profiler. JFR, or Java Flight Recorder, is a tool that previously it was a commercial tool actually from Oracle. Now it's for free. It's included in the OpenJDK, and it's not just put there and abandoned. It's actually still being improved. And so we have new features that bring new things that you can trace in JFR. There's something that's Linux specific. So yeah, if you use Linux also as a development machine like me, it's great, because usually the runtime environments are Linux, and then you are very close to your runtime. Startup time is a hot topic because it's related to scalability. Scalability nowadays is usually handled by running multiple instances of your application, and that means the additional instances, or typically containers, have to be started on demand, and they have to start quickly. Now we have still some new improvements in this area are coming to Java. We can make the JDK size smaller, which makes sense, because then we have less data to transfer to our runtime environment, cloud, whatever. And of course, we are trying to do as much as possible ahead of time, so that when the application is started, it already has classes loaded, objects prepared, and it doesn't have to lose time with this initialization work. And of course, to make something faster, one way is to make it smaller. For that, we have the project Lilliput that's changed the layout of object headers in Java to make them only 64 bits long, which is on a typical CPU, it's just one register because it's 64 bit. and it was found by surveys that many programs use relatively small objects. So if you have many such small objects, then this subtle change actually can save a lot of memory compared to the useful payload that you have in your memory. And of course, to keep Java fit and maintainable, there are some things that need to go away, like the 32-bit x86 stuff. And there's this old class from Sun called unsafe that is still used for some very special low-level memory access. Now you will start getting warnings if some library that you use uses this unsafe, because in the future, of course, the target is to try to nudge all the developers to try to use the standard Java API and not these non-standard ways of accessing things. And now we are getting to these preview features. Some of them are worth mentioning. Vector API, it's funny that it's already 10th times in incubator. The problem is, okay, first what it is about. We know that AI is everywhere, and AI usually involves a lot of metrics computation. And to do it efficiently, we can use so-called vector instructions of modern CPUs. And this vector API is aiming actually at being able to generate such efficient code for your CPU. The problem is there is still an ongoing Valhalla project in Java that should introduce the value classes. Those are classes that combine multiple fields but don't have a reference. And this is still not ready, so that's why it's expected that vector API will have to be changed. Structured concurrency, again, I already mentioned concurrency in the scoped values. That is nice that it's final. Unfortunately, structured concurrency is still in preview. Structured concurrency is something that helps you manage multiple threads. If you create some tasks that should run in parallel, typically you want to achieve something that if one of those tasks that run in parallel fails, that also the other ones are stopped and everything is nicely cleaned up. So you basically want to have some hierarchy, something similar to as you have these braces that encapsulate some, for example, for loop, and you want to be sure that once the for loop is over, that everything that was inside it is gone. We want to have something similar also for parallel processing. So hopefully structured concurrency will be final soon. And then the last thing, we have already pattern matching in Java. What makes it a little bit complicated are the primitive types, because they behave differently in Java. But there are also efforts to try to unify this. And one thing that we know happens with primitive types, that there are some automatic conversions, for example, from integer to long, or from character to integer, etc. And we would like to get rid of some useless casts because of that. Also, when we use the pattern matching, like when we use these nice switches that are based on types or instance of, so now we can check if for example an integer is fits into the range of byte, and in that way we can also use it in pattern matching. All right, that's it, and we still have some time for questions, and if you don't use this time, then again you can contact me later via my page and we can talk. Okay, let me check if I can see something in the chat. Okay, the technical problems that we fortunately solved. Why upgrade? Aha, okay. Code below super, is it possible? Yes, now it is possible with Java 25. Not any code. It has to be a code that doesn't refer to the object being constructed, of course, because we want to first make sure that the object is in a consistent state, then we can refer to it. But before the super, we can access the arguments that are passed to the constructor, and we can initialize fields, so we can assign to them, but we shouldn't read from them, as far as I remember. Looks like Java is going the Kotlin way. Yeah, definitely. Kotlin is renowned for that it takes inspiration from other languages. It's stealing ideas. So Java shouldn't be worse, and it should also try to improve. Of course, Java's approach is a little bit more conservative. So Java is renowned for backwards compatibility. So that's why many enterprises like Java. Want to begin learn this. All right. Java 25 can be used for complete AI programming. Well, definitely it can. Depends on what you mean. There are great libraries and frameworks that you can use to access AI or LLM models from Java, and abstract from which particular provider you're using. For example, LangChain4j, or if you're using the Spring ecosystem, then there's a Spring AI. And actually there are also but there are also some small models that you can run locally now, and there are many experiments also with Java doing this. Maybe if you know, Adam Bean is a guy who has a podcast, and he likes to mention usage of Java to really do a lot of AI stuff, or at least experiment with it. Of course, we are not most people won't create their own LLM, but there are some small models now that you can at least download and use. So yeah, it's still very dynamic, the AI space, but definitely Java has tools to do something high performance. I think the fact that, for example, Python is used a lot for AI is just for because the scientists are more aware or more familiar with Python, but actually Python has very poor performance usually, so it's not a great choice. Okay, as you mentioned, you also like Kotlin. Do you still see any benefits of using it instead of modern Java? Yes, I can see the benefits because, as I said, Java has a little bit different approach. Java is now 30 years old, and still most of the code that was written maybe 25 years ago would work with Java, which is great, but it also makes the evolution of Java quite difficult. It's not easy to deprecate things and remove things from Java. Kotlin is 20 years younger, so it could start from a much cleaner state. Another thing is that Kotlin has some interesting stuff. For example, coroutines. Coroutines are basically something that solves the problem of structured concurrency that I mentioned that is still in preview in Java. But even if you so everything has a pro and con because yeah you can use coroutines in Kotlin, but still it adds some complexity because you need to think if a function is a suspend function or not a suspend function. So both worlds can help each other because even in Kotlin you can use virtual threads if you run your program on a JVM, and then you can write nice imperative code without any suspend functions. So the spectrum, I would say it's not black and white. You can also Kotlin is great that you can combine it with Java. It has great Java interoperability, so you can decide that you take some existing Java code and maybe write tests in Kotlin, or you can write new stuff in Kotlin. So yeah, I think both languages make sense, and it's great that we have these options. How to become an expert from beginner and resources or recommendation? Well, this is an interesting question. I would say I already started mentioning LLM. I think I have to say I am a little bit AI skeptic because when I tell LLM to write some code for me, many times it ends up that I just get angry and delete the code and write it manually. But I think for what LLM can be great for is actually learning, because it's like a teacher that never gets bored, never gets tired, and that can be infinitely adjusted to your needs. So just you can just start your favorite LLM and tell it, okay, I have this task that I want to program in. It doesn't have to be Java, but whatever language you want to learn, and how would you do it? And or maybe you can write your code and ask it, are there any things that I do incorrectly or not in an idiomatic way that could be improved, and it will tell you, and or give me some pointers where I can learn this thing that I don't understand. So I think we've never had such great opportunities. I remember that when there was still Java version 1, I printed the syntax of Java on, I don't know, maybe 300 pages of paper, and I read it somewhere when I was outside, because I didn't even have regular access to a computer. Now we have access to the internet from our phones, and it's much easier to learn.
Yeah, thank you. So one I have a question. So like, if I know the concept, I can use it and then, learn about in depth. But I like to, know what, for example, let's take a stream. I like to know why stream exists, like why functional programming came in Java. So those kind of, history comes, why it's born, these kind of question I'm curious. Like, is it any structured roadmap thing to learn about
It's not quite clear, the sound, but I heard that you asked why functional programming came to Java, and not much of the details. But I can
it?
definitely
Yeah, yeah.
say something about that. I am a big fan of functional programming, and basically it's also very useful in connection with concurrency. Uh, the problem with concurrency is in the traditional object oriented or even imperative programming, you use a mutable state that can be modified anytime from anywhere, and it's very difficult to understand all the possible scenarios if these modifications can occur simultaneously, concurrently. With the introduction of immutable data types and functional programming, I think the main term in functional programming is function, or a pure function, which means something that takes some inputs and returns some output, and ideally doesn't have any side effects. So if you have if you have immutable data and pure functions, then you can be sure that whatever happens in that function doesn't influence other functions, and it's much easier to reason about such a program, even if it's executed concurrently or in parallel. So I think that's one great reason why functional programming is popular. Another reason uh, uh, is why the streams were introduced in Java. That there is a class of problems that it can be it is much easier to read for humans if it's written declaratively, and not the, like the implementation in imperative style. So instead of writing some loops where we modify some variables, for example, when we want to filter some objects and uh, find the maximum value from those filtered values, it can be hard to read that code from the that's written in the imperative style, and when we compare it to the functional style, it's much more intuitive, because you just write filter and find maximum. So it's exactly what the human expects. So I think these are maybe two very, very common advantages of the functional style. At the same time, for some other things, the object-oriented style may be better. Like, for example, if you have graphics, you can. It's very nice to model it using some objects, and also some other domains can be very useful if they are modeled using objects. So that's why the most popular languages, or two of the most popular languages like Java and Kotlin, they both are actually hybrid now. They allow you to choose the object-oriented style or functional style depending on where it fits better. Okay, so maybe if there's no other question, or did I miss something? Maybe let's check again. We used mixed Java Kotlin project and it works very well. Yes, great, good for you. Do you think module-lit architecture is better than microservices? This is again a very Pandora's box, this question. Well, yes, module-lit architecture is like a reaction to the some disappointments that came after the boom of microservices. Basically, everything can be overdone, and the point of microservices is not the micro. It doesn't mean the smaller the service, the better. The point of microservices is that there should be clear boundaries that are mappable to a domain, and then they can be stable and autonomous. If your microservices are designed so that every time you need to add some feature you have to change most of your microservices, then it doesn't make sense. It's the so-called modular monolith. So you have the same as you had with the monolith, just more complex because you have a distributed system that has a lot of pitfalls. At the same time, I think most architects usually nowadays they recommend you to really try to structure your application by modules, and when you are really sure that you want to invest in a distributed system, then you can change some of your modules into separately deployable microservices. So yeah, I think the modular monolith or modulith is definitely a good idea, and especially for new projects, it's probably the best way to approach. On the other hand, we have to be realistic, and if a project is above such some size, you usually can't avoid the distributedness. You usually have to communicate also to some external systems, or maybe you have some legacy system that you want to integrate your modern system with. So yeah, to some degree, it's very common that you need to handle some integration. I mentioned at the beginning that unfortunately we lost the space. Okay. So that's a challenge for Simona.
Yeah. I guess there are no more questions remaining for today.
Yeah, so then maybe we can wrap it up. And as I said, I'm open for discussing any interesting stuff, and maybe also there will be some future events where we can meet again.